and so forth. And in all of these situations, I dealt with people who were wonderful people, with a few exceptions here and there. So I think that you tend to be benign if that's your experience. And conversely, if you grow up in a situation in which you deal with crooks and thieves and murderers and various other things, you're not going to,
and there another dimension which is somewhat related to this, I think, is that perseverance. In other words, I've noticed many occasions when, years ago, before you would be coming to some conference, come hundreds of miles, thousands of miles, and come and speak for 10 minutes, or not 10 minutes, maybe 20 minutes, to a room maybe with 10 people in it. I remember it was some distinct experience. Could you say something about, perseverance? I mean, obviously
yes, I think I have that quality. I have that quality, and when things don't work out the way I would like them to work out, I don't give up. I don't become discouraged. I tell myself, don't give up. Don't give up. If I submit a proposal, it's turned down, I won't give up. I will say, okay, I'll submit another one, and so forth. If I try to become friendly with somebody and the person does not react positively, I will not give up. So yes, I think I do have this quality, and this quality has helped me tremendously, because many people have a tendency to give up 1, 2, 3 things that sort of discourage them, and they said, okay, that's it.
I see. Is there any, regarding that issue, is there anything, other than yourself, is there any advice that how people could, it's a very interesting quality. I think it's a useful quality.
Yes, I think it's an important, quality. But you know what, I think that in one's life, luck plays a tremendously important role. In my own life, there were 2 or 3 critical points. And I was lucky in that it went this way. And one such point was getting the job at Columbia University. Yes, that was lucky. And I go to, there were 2 or 3 instances where it could have gone this way, it could have gone that way. And sometimes, it's of crucial importance. For example, I was accepted as a visiting member of this. Suppose I were not. Okay. Well, quite possibly would be something quite different to this.
Let me ask you, of course, throughout the use of fuzzy sets, the history of fuzzy sets, the central question that comes up when you introduce fuzzy sets to people is the question of membership grade. This becomes the first hurdle that one has to come over. Could you just comment a little bit about your thoughts on the idea of membership grades and issues related around it?
Yeah. Well, many situations from, let's say, going back to the early history till now, when people get exposed to this concept, where do you get your membership rate, the membership function? Where do you get it? Well, fuzzy logic and fuzzy sets are used all over the place, but they're used in situations in which these membership functions are declared. In other words, designer interacts not with a human, but with a machine. But you're designing fuzzy logic transmission. You have rules saying if speed is low and torque is high, then do this or that. So where do you get the membership for low? You define it. You say that when I tell you low, this is what I mean. If I torque is high, this is what I mean. So this is what is called the declarative mode. So in most cases it is declared. It's not a matter of
learning or finding
or something. So, but right from the very beginning, this was a question that arose, and I gave a talk, I don't quite remember where, and there was somebody at IBM he was a linguist. And so this is the first question that he asked.
Absolutely.
Where do you get the membership functions from, you see? Oh, he said, these are context dependent. Tau to one person is not the same as tau to another person. So this sort of thing. So in most cases it is declared. However, suppose it is not declared.
Right.
Okay? I can elicit it from you. You tell me John is tau. I ask you, what do we by tau? It may be difficult for you to say, what's this function? But I can elicit it from you and say, okay, if somebody is 5'10", to what degree is this person tau? People can answer questions like that. When you go to see a doctor, frequently have to fill out a questionnaire. On the scale from 0 to 10, how intense is your pain? On the scale from 0 to 10, how frequently you cough and so forth, you see. Particularly today, you get more and more questions are from 0 to 10, more and more. So people, now humans have a remarkable capability to what I call graduate perceptions. I can ask you, to what degree do you like Obama? On the scale from 0 to 10, you'll be able to say, even though it's not a very well-defined concept, you'll be able to put it on the degree. And so people have this capability. So we want to exploit that capability. So I can elicit it from you by asking not right away what is membership function at all, but asking a series of questions. To what degree is 5'10" tau? To what degree is 5'8" tau? To what degree is 6'5" tau? And out of that, I'll get your membership function.
But there's another situation which I think is neither of the two, which is becoming much more important nowadays. It's not declarative and it's not learning. It's when you're dealing with the internet.
Yeah.
There's an internet, and fuzzy sets is clearly a tool. But internet, you're getting information that is being said, and you have no source that you could come and say, what do you mean by this? You know, when you read, let's say you read some article on the internet and you're extracting the information, how do you suggest that one could get the fuzzy shit and membership grades in that environment?
Well, suppose let's consider the problem of natural language understanding, something that I read very much concerned with. You read something and you say Robert is tall, but you cannot ask somebody,
That's right.
what do we by tall?
Exactly.
So in that case, then what you rely on is that in your head sits sort of in that context, perception of tau, so that you can ask yourself the question, okay, if I were to use this tau in some equation something, how would I interpret it?
Okay.
Now, recently I began to talk about the Z-mouse.
Yeah.
With the Z-mouse, you can easily do that. So, Z-mouse, you have a mark, we call F mark, scale, computer screen, and you enter your perception of a number on the scale. Now, the F mark is not a point, it's a fuzzy thing. Fuzziness in that context means that you're not completely sure what the value is. So if I ask you to what degree do you like Obama, you use the F mouse to put a mark, but not a point. Meaning that we are not completely sure really, to what degree you like Obama. It's a little mixed. So then what you can do there is this gets into fuzzy sets of type 2. So you get this membership function, but it will not be a sequence of points. It will be these F marks. So what it boils down to then, is that if there is nobody that you can turn to and ask to define the meaning of tau, humans have perceptions of tau, and so that if somebody asked you to what degree is so and so tau, you'll be able to answer that question. Just reading it.
Right, okay.
Just just reading it. Now, and that brings me to a definition of understanding, which is not conventional definition of natural language understanding. So my definition is the following. We do not have that. But if you had some sort of a cursor and you read text and you move it, and as you move it, you see on the screen what is happening. So you say Robert raised his right hand. You see somebody raising the right hand. This is what happens when you read the book. So some images
come up, yeah,
form in your brain. We do not have that, but at some time in the future, perhaps far away, we could have a system such that the images that are in the brain we see on the screen. At that point, we will say this is really understanding. It is not understanding in the sense it's used in natural language processing. It's not. It's understanding in the sense in which people really understand.
So it's the same way as when you talk to me and you say something, I don't have to make a fuzzy set. I can have a meaning of it in my own brain. So you say, well, John is tall, when you get somebody a present, say, he's pretty tall. I have an idea what he looks like, and I can go into a store and buy something for that person. Now, let me ask you another question, for you. Slightly different question, a little bit more. In some ways, as I see it, okay, in some ways that I see it, I want to find the exact term here. See, your work in fuzzy sets, and sometimes it's not mainstream, and somehow you're a little outsider in some sense, because the approach that you follow is a sort of constrained approach. That's and the other approach in fuzzy sets, in most parts, is one of building up. It's kind of using the rules to building up, and you're kind of using information rate to. Could you comment a little bit about that?
Yes. Well, that's correct. That's correct. If you look at the papers that I've written or I'm writing and so forth, they're not really in the mainstream. They're not really in the mainstream. And but I think that, but that doesn't bother me, because I think that it'll take time, but eventually people will warm up to it. I think in my discussions with you, you pointed that out a number of times in the past. Yes, that's true. Now, for example, I've been very much into computing with words and so forth. Not that many people, have followed me. Not that many people have followed me. But with the passage of time, more and more people will do. Now, right now, I'm interested in something that I'm very pleased with. I'm going to give a talk in the Logic Colloquium here on September 30th. And the title of my talk is, Can Mathematics Deal with Computational Problems which are which are stated in the natural language? So, all kinds of problems. Very simple one. Most Swedes are tall. What is the average height of Swedes? Problem state natural language. So, my contention is that mathematics cannot. But I can come up with a system that can. And that's based on computing with words. It's based on computing with words. And that opens a new vista for mathematics. See? Now, I hesitate to say that loudly if I'm talking to mathematicians. Who is this guy? Who's bugging us to say something for mathematics? But I think this is indeed the case. But at some point, this territory of problems which are stated in natural language, which at this stage is regarded as being outside of mathematics. So when I give this problem, because that's not a mathematical problem, for the probability theory problem that probably John is tall. What's the probability John is short? Whenever I give this problem, people say, the mathematicians say this is not a problem. When I I give it to something in probability theory, that's not a probability theory. Or else they come up with something that is not really correct solution. So at this point, what I'm saying is far removed from what is mainstream today.
Now, myself, my initial appeal to fuzzy sets has always been that people use fuzziness to simplify things. You know, when you go into a supermarket and you kind of want to find out how much it costs, you can say instead of $1.79, you say $2, and it's fuzziness. Now, in this regard, I found very appealing when you talked about extended fuzzy sets. Somehow, my understanding of extended fuzzy sets is that you don't really need membership grades. Do you have any thoughts on how you see this extended fuzzy sets?
Yes. Now, when you talk, I say loud, short, so forth, I don't appreciate it.
Right.
I don't give a membership on. And yet, you understand what I'm saying, and you can do something.
Right.
If I say raise your arm, raise your hand, you do it. Even though that's fuzzy, you're not saying what's the greater membership of this and this and this and that. If you're dealing with machine, robot, then you have to appreciate it. But humans understand certain things, many things, without the membership function being specified. So an extended fuzzy set or extended logic, let's call it extended logic, is a logic in which you deal with fuzzy sets, but the membership functions are not specified. So the example that I used involves using a spray can. You draw figures with a spray can. So I draw something like this. I say it's a circle. To what degree is the circle? Well, it's not specified, is it? Not specified. So, the point that I raised in the paper that I wrote and expanded logic, fuzzy logic, and so forth. How much can you do without specified membership functions? And in that paper I showed that you can prove theorems in Euclidean geometry without specified membership functions. You could do things in set theory without specified membership functions. Let me give you a quick example. Suppose I say, what do you mean convex set? And they say, well, convex set, something like that. And then I have, if you have two convex sets, the intersection is a convex set. You can prove that without defining convexity strictly the way it is done.
Nice.
I think it's an interesting concept.
I always found it to be an interesting idea.
Yes. I think that you have to be complimented for seeing much farther than many other people.
Thank you very much.
So it takes you 2 minutes to understand something. It's like another people 2 years to understand something.
Let me ask another technical question. Somehow in natural language, for example, people have talked about, of course, possibility theory becomes one way of interpreting, but another way is probability. People say, could you comment about, what are the benefits of...
Well, you need both. So, in my recent work, I'm using the concept of restriction, which is the same as your last say. So information is provided by restricting device of variable. I don't define the ways to find information there. And so a proposition in natural language restricts something. So you say Robert is tall, it restricts Robert's height. Now, so what's restriction? Restriction could be possibilistic, and I say, well, the possible values are such and such. What could be probabilistic? I said the probable values are such and such. What would be a combination of the two? So it's a mixture. Now, an example of that is this. Probably John is tall is an example. But let me give you an example which is a little bit simple. Suppose you have a number, x, and then you say, what do you know about x? I say, well, the probability that x is large is small. So I gave you some information about x, but it is not possibilistic. It is not probabilistic. It is a mixture of the two.
I see.
What is the probability that
John is doing.
is?
I see.
So you have a mixture of probability. So I'm not saying that you should not use probability theory. No, I'm saying you should use probability theory. But and I would say I'm not sure what 60%, something like that, is possibility, and 40% to 20% it might be probability, and 20% probability.
Do you want to give a break? Do you want to give a break?
Yes.
Break?
Can I take a rest?
A rest a little bit?
Yes, yes, yes.